Okay, so good morning. Okay, thank you for waiting. I'm sorry for that. So can you still hear me?
Yes po, Doc.
Narinig niyo na ako?
Yes po, Doc.
Okay, so we are now discussing respiratory system. So to start, these presentations came from Dr. Alfonso Lopez of Atlantic College, and upon seeing this one, you have this. A portion of this is incorporated in your LRP, and at the same time, it has similar references in your pathologic phase of disease. So most of the inclusions, yung mga basic nito ay nandito sa presentation. So I got this one. So maganda siya. And yung references din ni Dr. Alfonso, same with the pathologic base of disease. Mag-inject na lang ako ng mga updates, no? And some of the updates are incorporated also in the LRP. So this is our outline. So since maganda yung discussions na dito, and it will give you an overview on the respiratory system as a review with regards to its structure and defense mechanism, and in our next topics, it has a good presentations describing, okay, the pathologic lesions. Okay, so in these discussions, we will have a review on the structure and defense mechanisms of the respiratory system. So this is one of my favorite system, respiratory system, because I don't know, but siguro dahil konti, pero the lesions that can be found here are more of myriads, no, in focusing on the pneumonia. So later, yeah. So basically, not all problems focus on the lung tissue, but also with the other structures comprising the respiratory system. Okay, so to start with, you are familiar with the respiratory system. So when you think of respiratory system, you think of air, okay, oxygenation, yeah. Breathe in, breathe out. So the structures comprising the respiratory system is divided into three independent but continuous systems. So they have their means of syempre, same role conducting air that will go through, okay, the system, at the same time will help to expel out, okay, of that air. Other than that, they have this specific defense mechanism. So they have this defense mechanism that responds to a specific or a group of pathogens. Most of the time, at the conducting and transitional system, they have their is non-specific. Okay, so lahat ng pwedeng pumasok, they could react to that. Okay, and basically this is important as part of your ano yun, yung humoral, ayan, immune system. Ayan. Doon sa non-specific or innate defense mechanism. Okay, so we have three identified here. So you have the conducting system, the transitional system. References, the respiratory system is majorly subdivided into two, the upper respiratory system and the lower respiratory system. And in that references, more of the upper respiratory system are up to the transitional system. And the lower respiratory system is more of the lung, okay, the exchange system, and a portion of the transitional, yung nasa distal portion of the transitional, entering, okay, the exchange system or the lung tissue. Now, in this slide, no, it is detailedly represent, okay, the different constituents, okay, comprising such systems. Now, for the conducting system, this is consists of the structural component, the nasal cavity, the sinuses, the larynx, the trachea, and the bronchi. So from the outside to the sequential of the, what happened? Can you still see? Ako nawala. Ayan, bumalik na. Ayan. Okay, so please do remember the sequential parts, okay, of the structure or composition of the conducting system from the outside papunta dun sa inside. So start with the nasal cavity, kasama dyan pati sinuses, the larynx, the voice box na tinatawag, the trachea, and of course the bronchi. The conductive system is primarily of ciliated goblet cells. So take note, ciliated epithelium with goblet cells. So this support that in some way, in responding to certain exposure to the foreign or to foreign invaders or to foreign um, substances outside or in the environment, the body have able to respond to that. Like for example, creation of yung mga um, mucus from the nasal cavity. Ayan. So, because of the presence of the goblet cells. And expelling out, so may cilia tayo dyan. So, that will be triggered para mag-sneeze ka. Okay, so those are ways of how the conductive system respond, okay, to invaders, outside invaders. Another is the transitional system. So in the transitional system, this is exclusively consists of the bronchioles, which lined by, take note, Clara cells. So these are specialized cells, no? Non-ciliated secretory cells, and only a few ciliated cells. So these ciliated cells are more of found on those area kung saan matatapos yung conductive system. Then papaloob kasi siya, there will be devoid of cilia. That's why if you found out that mucus are present in that area, you may think of some metaplastic change that happened in the transitional system. So remember, we will going to use pathologic description to remember and of course to talagang clinically describe, okay, the problems or conditions that a system may experience. So that is the transitional system. Ulitin ko, exclusively composed of the bronchioles. So that is your respiratory and primary or secondary tertiary bronchioles. So how will you going to describe bronchioles or delineate that from your bronchus? So most of your bronchioles do not have a part of the trachea or cartilage. It's more of the smooth muscles lining. Okay, so aside from that, you might or you may describe the presence of Clara cells and non-secretory cells. Okay, and healthy bronchioles do not have goblet cells. That's why it is note here that healthy bronchioles do not have goblet cells. There are some tendencies a portion of the bronchioles have changed into ay goblet cells or presence of goblet cells. In that way, so makita yung change na metaplastic because of the continuous exposure to some mga injurious, okay, structure, okay, or injurious materials that the animal or that the human may inhale. Okay, and the last one, the exchange system. The exchange system, this consists of the alveoli that are lined by the epithelial type 1 or the membranous, which are important in the exchange, gas exchange, and of course the type 2 in the phagocytic activity and the surfactant produced. Okay, so yeah, so these are the very important compositions of the respiratory system, showing you the okay, the sub divisions. Okay, so always remember, that's why it was noted here that each system has a characteristic susceptibility to injury and specific type of host response and repair. And that depends on the presence of what microflora in a certain species of animals. Okay, so I've mentioned about the nasal flora. So this nasal flora is one of the component of the innate ng isang animal or an individual. So the presence of these are helpful. So since the nasal flora, the microflora in a certain mucous membranes are involved in the competitive exclusion. So I think that was discussed somewhere maybe in your bacteriology, okay, or role of your microflora is for competitive exclusion, in which they try to become the substrate for the entry of foreign invaders. That once these foreign invaders um, attach from these microflora, so there will be foreign invaders may be expelled out, not able to penetrating the underlying tissue. So without penetration, okay, hence there will be no entry of the possible pathogen within the system. But always remember that this microflora does not exist normal, okay, for the whole lifetime. Why? Because there are tendencies that the animal might be exposed to different factors that sometimes uh, parang origin of a secondary disease. Yan. Lalo na kapag the immune system is compromised. Okay. Yes. Ay, wait lang guys. Mga 10 minutes. Wait lang. Yes, I'm back. Ayan. So that is nasal flora. So, okay, so their main role is competitive exclusion. Okay, so next. Ayan. So this just shows you how the different microflora can be seen in different animals. So there are myriads of microorganisms that can be a part of the nasal flora. Like for example, in this animal, no, we have the dog. So in the dog, we have also some pasturella. Yan. So in other animal, we have also the shipping fever, okay, the Mannheimia homiletica as part of the microflora. However, these become disease. So ito yung mga disease na microflora that I've mentioned a while ago. If chances are the let's say the immune system of the animal is being compromised, or let's say the animal is seriously damage on this part of the system. Ayan. So possibly this can originate, okay, another infection. Okay, particularly the etiologies may be owing from the present microflora. Ayan. So I hope you are familiar with the atrophic rhinitis in pigs, which is caused by Bordetella bronchoseptica, which is a natural microflora of pigs, okay, found in pigs. So Mannheimia homiletica or the pasturella. Okay, mga pasturella species are microflora. You can also find that in dogs, you can find that in cattle, you can find that in pigs. Ayan, yung mga kennel cough, the kennel cough disease in dogs, one of the microorganisms, the bacterial microorganism microflora that can be seen also there is the Bordetella, okay, bronchoseptica. Ayan. So, the different, I reiterate ko lang, the different diseases of this microflora cannot be or can be different from different animals. So it might have the same Bordetella species in one animal, but its manifestation to other animals is different. So I mentioned about the kennel cough, since Bordetella bronchoseptica is one of the microorganism that can be part of the microflora in dogs. However, the Bordetella bronchoseptica that can be found in pig produces different disease. That is the atrophic rhinitis. Yeah. So di sila pareho, it's different. So that depends on the animal where this microflora is So this is just another picture also that different animals have microflora, and chances are in the tracheal air, yan, so dyan nakikita sila. So through experimentation, these microflora are very important for the respiratory defense mechanism. And this microflora is found in the conductive system. So very, very rich on that area, this kind of microflora. Massive in population, so bacterial organisms. Okay, so the respiratory system is constantly exposed to a myriad of noxious agents. That's why I've told you a while ago that in microflora, no, hindi for every yan steady. Okay, chances are they can also be a cause of the disease. Because, okay, yung nangyaring exposure or continuous exposure to some injurious entities, or let's say yung structure where this microflora, okay, are destroyed. Okay, so some of the agents that could affect, okay, the conductive system in which the microflora is also there, no, vapors, bacteria, viruses, particles, spores, gases. These are just common of the many agents that can cause or affects the conductive system, which in the long run, if not treated or controlled, might cause severe infection or severe disorder or disease to the affected animal. Ayan. So, very lucky, no, na kahit pa paano the animal may able to respond to this one. But continuous exposure and parang compromising of the immune system may succumb to this different noxious agent. Okay. So, the non-specific defense mechanism can be grouped into non-specific and specific. Okay, this defense mechanism that I've mentioned about in the non-specific, particularly found in the conductive portion, so they are very active in there. So we have the air turbulences. So this can be a work of the different crevices. Okay, dito sa may turbinating once air is exhaled, so they come through or flow into these different crevices. And that air turbulences is one way of parang filtering, okay, the coming in of air. Another is the mucus trapping. So I've mentioned about the ciliated epithelium plus goblet cells. So the production of mucus in there could drop. Okay, these foreign invaders. Another is the mucociliary clearance for the non-specific. So all possible foreign invaders that could enter on the conductive system could be trapped in the mucus, and the way of the conductive system may have mga ang tawag dito, signals. Okay, for the cilia, press of the cilia. So, expel out niya yan. Okay, so parang yun yung mucociliary clearance by means of sneezing. Okay, another is phagocytosis. So, syempre, there is non-specific mga sentinels natin, okay, mga non-specific blood cells natin that have phagocytic activities that could phagocytose in that area of the mucus or the epithelium where they could penetrate at that level, then maphagocytose sila. Another way of physical expelling out or mechanism is coughing and sneezing. Yeah, so these are non-specific. For the specific part of the defense mechanism, syempre, we have the antibodies which are being generated if there are uh, exposure to a certain condition in which antibodies are produced. So please do remember your different antibodies. You have your GAME, okay, GAMAT. Okay, in some instances, D is not present in all animals, but definitely we have the GAM and E. Ayan. So cell-mediated immunity is very important, especially when parang continuous exposure, okay, in which different cells are present now to upgrade, okay, the defense of the body for that particular foreign invaders. So next is the secretion. So very important for the secretion. So these secretions also help in expelling it out and diluting, detoxifying, neutralizing possible substances produced by foreign invaders. And of course, the antibody-mediated phagocytosis. So the antibody-mediated phagocytosis is being relied on the actions of specific antibodies being activated by certain microorganisms. So ito yung sa immunopath ninyo in the GAME or the GAME, there are some conditions in which a certain infection or certain microorganism could trigger a specific antibodies. Kung kailan mataas ang M or immunoglobulin M, kailan mataas ang immunoglobulin A, kailan mataas ang immunoglobulin G, and so on and so forth. Okay, so that is how it affects for the specificity for the defense mechanism that can also be found or seen as an action of on the conductive system. So the defense mechanism protect the respiratory system against the modality of what I've been mentioning. First, detoxifying inhaled or circulating toxicants and toxins. So this can be seen in the activity of the air turbulences, the secretions, the mucus trapping. Okay, neutralizing toxins and free radicals could be secretions. Okay, and of course, yung mga present of the on the antibodies and other cell-mediated phagocytosis. Trapping and removing inhaled or circulating particles, which is a major role of the mucus trapping, mucociliary clearance, and of course, the sneezing on which you can expel those trapped particles. And trapping, destroying, and removing inhaled and circulating microorganisms can be seen as a part of the non-specific and specific defense mechanisms of the respiratory system, particularly since we are talking on the conductive or conducting system of the respiratory system. Clear? Any comment? So I think I hear none. Now this presentation just shows you how bacteria can be cleared. Ayan, na meron talagang present on the conductive. So this just showing you that in a certain experiment, in certain hour, no, the lung can able to clear, or let's say the respiratory system can able to clear. Ayan, bacteria or any of the microorganisms. So that's how very effective, okay, in responding such exposure to different microorganisms. So on the other hand, so if these possible microorganisms are not cleared because of some impairment, then definitely in as short as a day or 24 hours, it might establish possible infection or possible disorder on that area of the respiratory system. Okay, so viruses are not the only factors known to predispose to bacterial pneumonia. So, ito na yun, no? If chances are the respiratory system have not able to clear bacteria, okay, or microorganisms that enters the respiratory system, they could, ito sasabi ko, establish, okay, the possible disease in the respiratory system, depending on how the pathogens penetrated on the different uh, subdivision, sorry, of the respiratory system. In the experimentation that they demonstrate, so the healthy lung rapidly eliminates inhaled bacteria. So take note, in a healthy lung and a healthy structure of the respiratory system, 100% can able to filtrate, clear, okay, the entry of contaminated, let's say contaminated kasi there are lots of particles in the air that could enter the respiratory system. So in such a way, no, there are some of the viruses such as infectious bovine rhinotrachitis, bovine respiratory syncytial viruses, parainfluenza 3 viruses, equine viral equine viral, I forgot the R. And then the feline FHB. Ano, nakalimutan ko. Herpes viruses, this temper have a remarkable ability to inhibit the pulmonary defense mechanisms, thus predisposing the lungs to secondary bacterial pneumonia. Okay, so take note of number 2. These are some of the primary, okay, these are some of the primary diseases or primary etiologies that could, okay, that could predispose the lungs to secondary bacterial pneumonia. Why the term predispose? So since the lungs can able to clear, okay, in a healthy lung can able to clear the entry of the air. Now, if there are exposure to, okay, yung exposure kasi depending on the volume, the dose, and the let's say the body constitution, ibig sabihin yung immune system of the animal, okay, pwede siyang mag-predispose. Kung kaya ng katawan, okay, especially the respiratory system is normal and the other support system is normal and healthy, then these primary etiologies for a certain disease can be able to clear up and do not produce or predispose pneumonia. Okay, so provided na healthy. Now, kung hindi talaga, this secondary bacterial pneumonia can be those that I've mentioned before, the microflora. Or if not, there are some could be developed, okay, out from the initiations of these viruses. But definitely, most of the time, yung secondary bacterial pneumonia dito na nagkukos dun sa lungs na affected animal could be those microorganisms that are normal flora previously. Okay, so viruses are not the only factors known to predispose to bacterial pneumonia, also known to impair bacterial clearance in the lungs. So I mentioned this one, continuous exposure to dose, volume, ayan, frequency. So these are the considerations. Saan? Sa stress, dehydration, some problem, inherent problem, pag lung edema, if there is a congestive heart failure, uremia, yan, so end stage of kidney disease, ammonia exposure to toxic gases, and of course, worst is the immune deficiency. So these are the other considerations that will impair the bacterial clearance of the lungs as well as the other portions of the respiratory system. Take note lang, ang hina-highlight kasi dito is the lung. So since lung is one of the major component of the respiratory system that is very crucial, okay, once affected by diseases. Kasi this help in the oxygenations. Just like in the cardiovascular system, the heart is very important. Though all other structures are important kasi they support the activity of the heart and the circulatory system. Same with the respiratory system. The lungs may be the most parang important system or support mechanism or structures are needed to complement and to maximize, okay, the activity of the respiratory system. Okay? Okay, so I've mentioned this again. So the defense mechanism, the conducting system are mainly of air filtering and particle removal. So if you will notice, no, yung nakalagay dito, so those reflected in the pyramid, yeah, it's like the triangle here, the conducting system, came from the mix of the non-specific and specific defense mechanisms. So since the defense mechanisms that are observed in the conducting system are mainly air filtering and air turbulence, centrifugal forces. This is how the movement of air or the turbulence of air will enter, okay, the nasal cavity. The particle impactions that can be trapped within the mucus and of course in the cilia. Yan, the mucus entrapment, and then of course the mucociliary clearance that can be initiated once there are trapped particles. So magkakaroon yan ng mga signaling or triggering that could trigger the sneezing mechanism or yung response to sneeze out to expel out, okay, those particles at, okay, those particles that enters at, okay, or up to the conducting system. So remember, saan yon? Nose, trachea, and bronchi. Okay. So another rich in secretions. So ibig sabihin, at the conductive system, there are secretions. So basically, napaka obvious naman because mucus are secretions. And part of their secretions is the presence of the immunoglobulin A. So these are the defense mechanisms critical in the conducting system. Okay, so these are the first line of defense against inhaled particles. Okay, particularly of the air turbulence and centrifugal forces. So I've mentioned this in the nasal turbinates. Okay. So this is a picture of the nasal cavity showing you the conchae, the different conchae, ayan, kung saan may mga crevices in here, and very vascular. Okay. So the narrow spaces, ito yung mga narrow spaces, are located between concha, the dorsal, middle, and ventral meatosis. So ito yung mga openings in its concha or conchae. Okay, so this is where the expired travels within the nasal cavity. So remember, may papasukin siyang mga crevices, and these are the meatosis where it reflects like a crevices, kung saan nagkakaroon ng turbulence, okay, at air filtering na for the air. So, for its histology, The mucosa that I mentioned is a pseudostratified ciliated epithelium and with numerous interspace or intermingling with a goblet cells. Okay, so these goblet cells, as you can see, ito yung mga para siyang globus. Okay, para siyang ano kasi, that's why it's called goblet cells because they resembles like a goblet. And particles inside are the secretions of the goblet cells. So, at top of the goblet cells, we have the cilia. Okay, yung different yan, mga ciliated. Okay, they are pseudostratified because it seems like they're stratified. However, they're all attached in a basement membrane. The BV here are the blood vessels. That's why so all parts of the respiratory system are very vascular. That's why it's very difficult whether to say that the oozing of blood, okay, na makikita nyo outside pag nag-bleed ka sa nose, came from the conductive, transitional, or the bottom. Kasi all of that is bright red and fresh blood. Not unlike in GIT, you can delineate whether the hemorrhage could happen on the proximal portion or the distal portion of the GIT because of the descriptions or characteristic of the blood that can be observed in the feces. Okay, so ito lang yung parang bad side or negative sides pag sa respiratory system. Okay, because of the freshness of the blood. Okay, now you cannot delineate whether some portion of the respiratory system came from. Okay, so the proportion of goblet cells to ciliated cells decreases towards the distal portion of the conducting system. So, true to what I mentioned before, no, pagdating sa transitional, there is limiting in the goblet cells and cilia. Okay, so in other words, the terminal bronchi have proportionally fewer goblet cells than the nose or trachea. Okay, so the submucosa of the conductive system is highly vascularized with many blood vessels. So this is the submucosa, just underneath the basal lamina of the pseudostratified ciliated epithelium. So this is where also secretions, some phagocytosis could happen on the submucosa. Okay. So yeah, this is how it happens in the mucociliary apparatus and the mucociliary clearance. Okay, so this is a caricature showing you the mucosa, the trap particles, and how the active goblet cells produce or liberated its secretions. Papunta siya sa mucus. So yun, ciliated cells have approximately 200 cilia per cell. So that's how much in number, no? And top of this cilia is a layer of the mucus. Ito yan. So, impacted the mucus are quickly removed by mucociliary escalator. So, palabas. Okay, this apparatus is known as escalator, which is composed by ciliated cells beating approximately 25 times per second. So, ganun kabilis. Okay, yung movement niya. So, this estimates the bacterial mucociliary apparatus moves and deposited particles at a rate of 1.5 centimeter per minute. So just imagine how parang busy, okay, and active the tracheal mucociliary apparatus. That's why if there are micro organisms that stop the activity of the cilia, ito yung ciliostasis, no? Then impairment of conductive system to conduct its filtering and expelling of microorganisms. So what happens that this microorganism could enter the other parts of the respiratory system. The good point there is that the transition have its parang group of defense mechanism. Kaya if ever some microorganisms parang pass through, okay, from the activity of the conductive system, then another group of defense mechanism will be present in the transitional system. So at this point, pwedeng decontaminate ulit, okay, or let's say ma-neutralize or ma-expelled out Okay, yung microorganism. So later we will see in terms of sizes of particles kung paano siya makakapasok hanggang doon sa lung. Okay, so ito lang yung examples of the air turbulence with the myiasis. And this is the different concha. Ayan, the conchae with characteristic coiled appearance, creating air turbulence during inspiration. So, okay, these are the particle size. So, ito pala yung sasabi ng particle size. On the nasal cavity, so larger than 10 micrometer can enter or can be trapped in here. However, smaller than that, sa bronchi na siya papasok, 10 to 12 micrometer dyan. And kapag mas maliit pa dito, then it can go through the alveoli. So, lower than 2 micrometer ng lungs. So, the lungs have its own group of mechanism. Okay, so why is it important to see the structure or the healthy structure of the concha or the myiasis? So since ulitin ko ulit to reiterate it more, so the conductive system main function is air filtering in air turbulence. Kapag walang mga concha or structures like this, then there will be impairment of the air turbulence and the possible trapping filtering of the particles. So when will this happen? Like for example, so I mentioned about atrophic rhinitis a while ago. So atrophic rhinitis is a disease in pigs in which the turbinates, the nasal turbinates are degenerated. Why degenerated? Because of the presence of the toxins produced by bronchoseptica plus another microorganism, the Pasteurella maltosida, the A and T, ano yun, toxins nila, that is epitheliolytic. Okay, or yung pwedeng osteolytic. Okay, pwede niyang i-dissolute, okay, or dilute, tama ba yung dilute? Or pwede lang parang tunawin, okay, yung soft, okay, membranes or the soft bone or cartilage of the turbinates. That's why in very active, okay, yung disease na yan sa kanila. Or very predisposed because of the developing turbinate. At mas madali yung ma-destroy. So, if that happens, now, imagine a pig with disturbed respiration, okay, because of the destroyed turbinates, then it will possibly that the animal may be predisposed to more severe or more serious problem. And that problem could enter, okay, up to the lung. And sometimes the common the common ano yun, problem that can be expected is the aspiration pneumonia. Ayan, dun sa lungs. Kasi the filtering, so wala nang clearing of the inhaled air or particles, that it could trap up to the lungs. And that is aspiration of particles which can cause pneumonia once this facilitates inflammation of the lung tissue. So that's aspiration pneumonia. So that's a common sequel for the turbinase destruction. Okay. So the mucociliary clearance. So we've mentioned about the air turbulence. Yan. So sa mucociliary apparatus. Yan. So now the mucociliary clearance in bronchi. So since bronchi is a part of the conductive system, this is the distal portion of the conductive system structure. So the anatomy, the particles that can be trapped in here is 10 to 12 micrometer. So as you can see in the picture, on the part of the airway, so the bronchi actually the airways. Okay, so in here, no, sa the bronchial part, okay, the bronchi structures, meron din tayong mga associated lymphoid tissue. That is your aggregated. So these are aggregated lymphoid tissues that can be found in the tissues of the respiratory system. That also helpful, okay, in maximizing optimization of the immune system, especially yung non-specific immune system. Okay, so Some of the smaller particles suspended in the inspired air bypass the nasal cavity are trapped on the bronchial bifurcations. Okay, so strategically, this is where bulbs are situated. Okay, so these bulbs are structures of the lymphoid system. So nandun yung term natin lymphoid nodules, no? They actually involved in the immune system activity. Expelled from the conducting system by the mucociliary movement. So, pwedeng bahing or pwedeng coughing. Okay? Okay, so this is the picture naman once particles could enter the alveolar or alveoli, okay, yung lung tissue natin. So, there are different movement or different group of defense mechanisms that can be found. Ayan, so we have the PAM, that's the alveolar or pulmonary alveolar macrophages. Ayan, and of course, yung mga fluid present in there. Ayan. So, ito yung possible means of defending the gas exchange system. Okay? Okay, so this is a picture of the pulmonary alveolar macrophages. Sometimes this pump can be found in these interstitial spaces. So you may mga, these are resident cells actually of the pulmonary organs or the pulmonary tissues. So you can find them in between, so interstitial spaces, or if there are, let's say, infections or some foreign invaders, they can be seen infiltrating one alveoli and phagocytizing. Okay, yung mga particles. So this alveoli here shows you small mucose plus yung particles natin, some inflammatory cells and polymorphonuclear cells here. So definitely we could expect that this pulmonary alveolar macrophages will clear up this one through phagocytosis. Cells, okay, of the pulmonary, okay, tissue. So this is a picture of a bronchoalveolar lavage showing you an abundant macrophages with vacuolated cytoplasm. These vacuolated cytoplasms are those entities being engulfed by the macrophages. Okay. Okay, so bacteria are in the size range of 2 micrometer or below that can penetrate to the alveolar region. The pumps are the main derived blood monocytes with phagocytic activity, and thus the antibodies are not required. So once phagocytosis is taken place, these pump move to bronchioles, and from there, phagocytic cells are removed by the mucociliary escalator. Now you can see they might be a different system, the respiratory system, but they are continuous. That's why in the first discussion or the first description, systems comprising respiratory, but with continuous characteristic because of their, in terms of its functionality. Okay, so PAM is the main effector cells in the inflammatory process of the lung through production of cytokine. So when cytokines are liberated, o mas madali na ngayon yung clearing up, okay, of the microorganisms or any particles present in the tissue mentioned. Okay, however, excessive release of proteolytic enzymes by pumps can result in lung injury. Kasi ito na yung excessive inflammatory responses that these uncontrolled or yung maraming may create, okay, bad effect on the area. Kasi may facilitations para mas mabilis ngayon to the point that the normal one can be exposed to instances of exacerbated inflammatory response. Kaya doon nagkakaroon ng injury because of the cytokines also. Okay, so this is the summary showing you the history of the nasal cavity, lined by highly vascularized mucosa with abundant blood vessels in some mucosa. It's a part of the physiological function to warm up the air that will reach the lungs. So in one way, the respiratory system also are involved in the thermoregulation. Ayan. Okay, so because of this abundant vascularization, these are the conductive system is also prone to hemodynamic changes such as hyperemia, congestion, and hemorrhage. That's why in your assessment, kapag nagpi-physical examination kayo sa mga mucous membranes, and upon necropsy nakikita nyo, minsan may congestion, hyperemic, or paling on the area of the nasal cavity or part of the cavity on the parang face. Okay, facial cavity, makikita nyo dyan. Okay? So, ito na ay disturbances that can be observed in the conductive system. So, we've mentioned about congestion, hemorrhage, and hyperemia as the major changes because of its vascularity. Now, the most common two, okay, disturbances in the hemodynamic changes is the epistaxis and the hemoptysis. The epistaxis is bleeding, so nose bleeding, and the hemoptysis is one way of expelling, okay, blood, okay, through coughing. So epistaxis is a medical term describing a nose bleeding, and hemoptysis is coughing out of blood or presence of blood in mouth, saliva, or sputum. So these two are commonly seen or individually in an animal. Okay, so important kanina. So the characteristic of blood that came out from, or that coming out from the respiratory system is always bright red or always fresh. Okay, even if it originates from the innermost portion of the respiratory system. Not unlike in GIT that when hemorrhage take place in the small intestines, so once the remnants of the blood clot, okay, those pieces may be dark, which is the melena. And if it is bright, then expected that some of the hemorrhage can originate from the lower digestive system. So dito sa respiratory, regardless, so say it's all fresh in all part of the system. So that's the epistaxis and hemoptysis. For nasal congestion na hyperemia, so ito yung cavity of a cow with tympanic, okay, tympany or yung tympanic status or the British kasi kaya TI. So tympany or bloat. So the pressure that will be move, okay, papunta sa harap, okay, pushing, okay, throughout to the upper portion of the conductive portion, no? So that will compress, okay, the affected tissue, okay, of the respiratory system. That's why my congestion tayo at the same time my hyperemia. So nasal congestion hemorrhage is frequently seen in bloat, toxemia, sepsis, inhalation of irritant gases, and of course, inflammation. And epistaxis is the frequently indicator of nasal trauma or nasal neoplasia. So nasal trauma, pwedeng may natusok or something traumatic injury that could release RBC or blood from the cavity, or if there are space-occupying nasal neoplasia. So these are the differential diagnosis that you will consider once assessing an animal with epistaxis. Ayan. So in cattle, epistaxis hemoptysis is associated with ruptured pulmonary vessels because of aneurysm. In horses naman, if there is exercise-induced pulmonary hemorrhage and ethmoidal hematomas. Okay, so pressure, pressure derived, okay, yung problem natin. So careful exam of the respiratory tract is required to localize the source of bleeding. So that's how it should be assessed when it comes to evaluation of hemodynamic changes in the respiratory system. Okay, this is an example, ethmoid hematoma in horses. So organized blood clot. So ito ay parang it can create pressure kasi medyo malaki siya on this area. So this could be characterized by chronic, progressive, generally unilateral nasal bleeding. So this concha, it could look like a tumor. Unilateral epistaxis, ibig sabihin kung saan conscious siya affected, doon lang siya nagkakaroon ng bleeding, and surgical removal can also be done. Okay. So microscopically, the mass is composed of a thinly capsulated mass of connective tissue. I mentioned about hematoma, pare-pareho lang naman yan, containing blood vessels, red blood cells, large numbers of CD5 and few leukocytes. Okay, so that's how the response of the conductive system in terms of yung different external environment exposure. Okay. So this is an example of nasal congestion and hyperemia in terms of inflammation. So you will notice here fibrinopurulent exudates. So that means that there is a violent, okay, so parang cause of the disease that led to the liberations of fibrin. Okay, so purulent may contaminations of pyogenic bacteria. So yan. So this is a hemisection of cow with rhinitis or the infectious bovine rhinotrachitis. So I mentioned a while ago that this virus caused the IBR can be a primary predisposing factor to secondary bacterial infections. Now, the secondary bacterial infections that can be assessed in here, ayan, ay yung mga pathogenic bacteria kasi it causes fibrinopurulent exudates. Okay. So what else? Nasal congestion or nasal hemorrhage is commonly seen following exposure to irritant gases such as ammonia, hydrogen sulfide, nitrogen dioxide, ammonia, and other toxic gases. So these also results of rhinitis. Okay. To add, before ko makalimutan, the most common manifestation kasi ng viruses is more of congestion and hyperemia. So other than that, lesions like pus or mucopurulent, etc., are a product or establishment of contamination by pus-forming bacteria. Okay? So, kung kaya ng katawan, hanggang red lang yan, and some expulsions ng mga fluid because of congestion hyperemia. But if you will notice changes in the mucus produced or yung consistency at may exudate na, then you will now go through more assessment of possible secondary bacterial infections or progressions also of the disease. Okay, so nasal injury, repair inflammation, rhinitis. So always remember that the nasal cavity, rhinitis is also common, okay, depending on the exposure yan. So may inflammatory conditions. So rhinitis is inflammatory conditions of the nasal membrane. Okay, so ito lang, a common cold as exposure to changes in the environment. So to illustrate the mechanism of injury and host response in the nose, let's use an example of the common cold. So when you become infected with the virus of the common cold, the infected cells in the nose first degenerate. And there is mild inflammations in the nasal mucosa, which cause pain, running nose and eyes, and finally through mitosis and cell migration, these excoriated cells are now being replaced by new nasal epithelial cells. So this is good in epithelial cells because they have the capacity of regeneration. So I just this slide just let you know the sequential way of repair or regenerations of a damaged nasal membrane. So this is how it looks like, no? We have the cell injury exposed to the nasal cavity. So there will be degeneration. So dito tayo sa 6 cell natin, no? So ibig sabihin, the capacity of the system to adapt for that ay hindi nagawa. So there is degeneration. So after degeneration, the affected cells could detach from the basement membrane. Always remember that in epithelial cells, once cells are detached from the basement membrane, they are already gone. That can be a way for penetration kasi ma-open siya. Okay, just sa basement membrane. And definitely the cells that are being detached can die. Okay, so afterwards, my detachment, then full exfoliations of the affected cells. So in that exfoliations may trigger a regional or local inflammations. That the local inflammations will try to neutralize and try to parang bring to normal through repair or regeneration. Kasi di ba, the fluid, the substances, etc. that are present, the inflammations are very rich, okay, that support in the restoration, okay, of the tissue involved. So aside from that, there will, once parang restored, there will be mitosis. That to increase the number, okay, or replace the number of cells affected. And if that happened, then repair to that affected nasal cavity now will be finalized. Okay, so this is how it looks like in the repair of injured or degenerated nasal mucosa. Okay, so it's just mentioned here that lesion stages of repair similar to all levels of conducting systems. So pare-pareho lang yan. At all levels of the in viral, toxic, and traumatic injury. So these are common because these expose the immune system for the viruses, no, to develop, okay, a secondary bacterial infection. Toxic, so direct, ang toxic and traumatic injury are direct destructions of the affected nasal mucosa. Okay. So, ito yung kanyang caricature and the comparison for the normal ciliated epithelial cells with no exposure to possible entities. So, example here that they mention is virus infection. So, once there is replication in the nasal cells, it will now cause degeneration. So, once degenerated, my detachment and exfoliation. So yan. So note the ciliated cells detach from basement membrane and exfoliate to leaving large portions of the mucosa ulcerated. So sabi ko nga, once once cells are detached from the basement membrane, there is the opportunity for microorganisms to penetrate, okay, that membrane. So since basement membrane remains intact, repaired by mitosis and replacement of new cells is remarkable. So always remember, if you are following an assessment in the parang repair of a certain condition, no? So titignan nyo yung mga involvement of the different cells on that area. How it looks like when there is exfoliation, exudates, and repair. So we have there the mitosis. So, ayan, makikita mo naman yung dalawang, metaphase, anaphase, or prophase. Ano to, guys? Are you still there? The mitosis here, is it what stages of mitosis? Prophase, anaphase, metaphase, etc.
Anaphase.
Ah? Ano no? Telophase.
Anaphase po, Dok.
Anaphase? Sigurado ka, Miss Jillian? Mas malapit pa yung yung telophase natin in which dalawang daughter cells kasi meron na tayo cleavage dun sa gitna, tama? Nasa end stage nga ng late stage of late stage to early stage of the telophase kasi meron na tayong daughter cells, meron tayong cleavage dun sa gitna. So, makukomplete na yung kanyang mitosis dun sa area. Okay, so yan lang yung nangyayari in terms of regeneration, no, and repair of the affected nasal mucosa. Ayan. Okay, next. So it was also mentioned here that after the degeneration exfoliations, chemotactic factors such as leukotrienes, the complement factor 5, and others, especially mga interleukins, are located in the submucosa part and affects tissue-producing exudation of leukocytes in the surface. So this will facilitate now the repair, okay, and regenerations of the affected mucosa. Okay. So this is summary of the injury repair. So exposure within of 10 to 14 days, complete repair. Okay, regenerations of detected mucosa is facilitated. Okay? So napaka-importante nating malaman to. Why? Because during our intervention in the treatment, if we understand, okay, the repair and regenerations of a certain mucosa, provided that the animal have are a little are apparently healthy, no, that could probably facilitate this um, repair process. Okay? Walang impairment. Ayan. So, in 10 to 14 days, new, okay, or healed epithelium can be observed. So, Doc, will it possible na walang healed? Yes. That is through exposure or yung complete, not complete, but continuous exposure of the microorganism plus exacerbating environmental factors. Kaya na-overcome yung activity of the immune system to facilitate this repair, particularly in the affected epithelium. Okay? Okay, for the take-home message, yes, tapos na. I will end this one kasi medyo overloaded. So the respiratory system is divided into three dependent but continuous compartments. Independent in a way that they have their structures and responses and of course the defense mechanism. So these are the conducting system, the transitional system, and the exchange system. For the conducting, we have the nostrils, the trachea, and the bronchi. And for the transitional, we have the bronchioles. And of course, the exchange system, we have the lung tissue, particularly of the alveoli. So the conductive system is light. This is the main structure for the defense mechanism. Pseudostratified ciliated epithelium, and its main defense mechanism is trapping and removal of particles by mucociliary action. So yung air turbulence, ayan. So, L-filtering. Ayan. So, the transitional system is lined, ciliated, and non-ciliated secretory epithelium and its main defense. The ciliated is diminishing high, not always yan. So, nandun lang siya sa area wherein the bronchioles, yung susunod lang doon may konting ciliation, but while it go deeper, then there will be no ciliated epithelium and goblet cells. Wala na dyan. Okay, so the alveoli is lined by alveolar type 1 with membranous and pneumonocyte 2 for pneumonocytes. And the main defense mechanism is provided by the pulmonary alveolar macrophages. So in addition, the lung has defense mechanism against toxins, circulating organisms, and locally produced free radicals in the presence of the alveolar macrophages plus the activity of other innate and antibodies, and of course yung cell-mediated, the cell of the innate, okay, immune system. Yan. Okay, so the mucosal surface of the proximal conductive system supports the growth of a vast population of organisms. That is the nasal flora. And organisms of the nasal flora are carried into the bronchi and lung by inhaled air, but the organisms are properly eliminated by the defense mechanism. That's why this is the support of possible establishment of disease na papunta dun sa lungs or producing pneumonia, in which the particles once identified ay mga microflora pala. So it is possible that the microflora from the other systems can be inhaled through papunta sa ano sabi ito? Lungs. However, in health, no, sa lungs can able to clear up those microorganisms. So the lungs can be exposed to aerosols of bacteria, but within 24 hours, provided that the lung and the other support system is healthy, then within 24 hours, it can be destroyed. So virus, stress, dehydration, lung edema, uremia, ammonia, and other forms of immunodeficiency reduce the pulmonary defense mechanism, thus predisposing the lungs to secondary bacterial pneumonia. So the nasal mucosa is vascularized, that the major response in the hemodynamic changes are hyperemia, congestion. Yan. So which also be a cause or a predisposing manifestation of the bloat, toxemia, sepsis, and rhinitis. So, hemorrhage in domestic animals are common. Nosebleed or epistaxis. Ayan, yung applications natin. While hemoptysis or saliva or sputum present, okay, once coughing, no, coughing of blood yan, ay pwedeng mangyari. So, in epistaxis hemoptysis, it's not possible to determine the site because of the freshness of blood being spelled out. So, common cause of epistaxis in horses are ethmoid hematoma, exercise-induced pulmonary hemorrhage. Or if you have heard about the COPD, so later we will talk about that, how the COPD affects the lung also. Okay, na nagkakos din ng bleeding. So in all species, nasal tumors and rhinitis are also cause of epistaxis. Yes. So the nasal mucosa has remarkable ability to repair. So in 14 days or 10 to 14 days, provided that the support mechanisms, okay, of the repair is there or adequate. So the degenerated or affected nasal mucosa can be replaced by new one within 14 days. Okay, so I think that's all for the discussions of the introduction for the defense mechanism of the respiratory system. So do you have any question? Are you still with me? Did you follow? Okay naman? Ba't ko konting estudyante ko, sila lang sumasagot. Okay naman?
Yes po, Dok.
Okay. So please supplement again, okay, by reading. You know, it's sa akin kasi very interesting ang respiratory. Though, cardiovascular also interesting one. Pero dito, dahil paborito ko, I hope you can find favorite system nyo para mas madig nyo pa yung informations regarding this. So hopefully, I can able to experience in the respiratory system. Okay, lalo na dun sa mga na-expose ko. Pagdating natin dun sa sa mga deeper part or dun sa mga later. So in here, just do read. Okay, just do read for us to have a smooth discussion para hindi kayo mawala dun sa discussions natin. Okay, so I think that's enough for today. I guess we discussed a lot. Kahit pa paano overload, yan, hindi nyo na rin maintindihan. Okay, so if you have questions, you can raise now. If you have clarifications in our laboratory, you can raise now. Yes. Natatakot si Kate eh. Hindi pa. Kasi meron pa tayong discussions ng Wednesday and Friday. Ayan, di ba? Okay. Okay, so if you don't have any question, clarifications, thank you for today. Thank you for listening. So I hope you've learned at least 4 or 5 parang terminologies to start, okay? Learning more of respiratory system. Thank you very much, everyone.
Thank you po, Dok. Thank you po, Dok.